Hello and welcome back to the lab. Today on the bench we have a return visit from my HP. What was this thing? I have to look at the case. 122A. This is a vacuum tube based scope. It does have a couple of transistors in it, so it's not all tube, but it's nowhere near all transistor either. And I had this out and running. It was doing quite nicely. We were doing some demos, some ham radio demos, and this was part of a radio station both through the stages as well as through the eras. This scope partnered with this spectrum analyzer to show essentially how a radio station worked from microphone to transmitter. And it was running all day. So with it running all day, it developed a fault, so now we're here to fix it. I have taken the case, or I've taken the scope out of the case because I know what the fault is. I was there when it went south. But that's all we've done to it. I haven't done any troubleshooting, haven't done anything, so you guys know as much as I do. You know there is a fault. I'm going to describe it here in a little bit. And we'll go through the troubleshooting process, see if we can't get this thing fixed again. So essentially, I lost intensity control. The switch still works, on and off. But the intensity control went to a medium intensity and just kind of stayed there. Didn't do much of anything, couldn't control it, so when I needed to blank the screen, I had to turn the scope off, let it discharge. Of course, with it being vacuum tubes, took a bit to cool off, took a bit to come in. But it got us through the day. I don't think it's power supply related. I did take a quick look at the schematic, which we'll get into here in a minute. But we're going to try something first before we look at the schematic, and then we'll go from there, because something caught my eyes as I was taking the case out, which I will just turn this way. We'll lay this down right here. So in this particular scope, all the high voltage stuff is back here. There's some high voltage stuff under here. The TO3, I believe, is under here. I think TO3 sits right here because there's two transformers in this, and I can see the one in the back. I think the other one's right here, but I'm not 100% sure yet. However, if we take a look over here, and of course what I want to record is in shadow, there is a capacitor across the intensity potentiometer. So if that cap's shorted out and has gone bad, that's going to do some weird things for my intensity control. Now, I didn't overload it. Fortunately, on this scope, there's a intensity limit control, which kicked in, so the tube didn't go super bright or anything like that, so it wasn't torturing the tube. But it was not ideal. So what we're going to do first, before we do anything else, is we're going to take this cap out and measure this and test this to make sure it's not just a simple cap decided to go away in the middle of a demo. Removing the intensity control got me better access to this bottom pin so we could do this capacitor. And since we have it out, a quick check of the potentiometer, sweeping it just back and forth. Looks like the pot's okay, so I don't have any questions about putting this all back together. So let's go ahead and put it back together and see if we still have the problem. Okay, I've got the control put back in, and we'll go ahead and give it a turn on. I don't have it on the current limit supply. I'm not worried about the power supply rails, as it's been on for 8+ hours recently. But we are on the isolation transformer. We'll give it a warm-up. Now, if we don't... oh, I saw it. Okay, that might be... Oh, nope, there it goes. It's coming back. That might be a problem. We may still have the problem. Okay, that's weird. I have a control that's not working now that was before. All right, so that's B. A's not moving. Well, that's yet even more of a problem. All right, well, I have brightness control. So the brightness limit may be the problem, because I did not have intensity control before. The intensity control did not do anything. But where did my A go? Oh, it came back. There. Oh, there it is. There it is. This pot needs some cleaning, apparently. I get brighter. Let's check a schematic, because we may have intensity limit problems now. All right, after poking around on the scope a little bit, taking some measurements when it was off, things like that, I found a couple resistors that had drifted out of tolerance, and I was kind of racking my brain as to what might possibly be happening. And we'll take a look at the schematic here in a second, but grid control is ultimately the problem, but it's actually a bias problem, it seems, not a control problem. I have control, I just don't have enough control. So I'll turn the scope on, and we're going to measure the negative 2,000 volt supply. Now, this goes without saying, if you're not comfortable and you're following along, do not take these measurements, do not do these. We have to have special equipment to not hurt the meter and to not hurt ourselves. So we are about to measure the 2,000 volt supply. I'll show you guys where the vacuum diodes are here in a second, but I'm going to take it off the plates of the vacuum diodes. And what we've got going on is right here is a vacuum diode, and we have 2,411 volts. So this is a divide by 1,000 probes, so we have to multiply, or sorry, divide by 100 probes, so we have to multiply this by 100. So where it was 2 point, I'm only presenting 2 volts to the meter, but at the probe tip, I'm measuring 2,000 volts. Same thing over here. We'll hit the vacuum diode, 2,449. Now, if I take the intensity control, I have control. I can move things. So my oscillator's responding. The scope is behaving like it should. The problem is I don't have enough adjustment range. We have a little bit of adjustment there. We have lots of adjustment here. So we start at 20. Whoa. We start at 2448. Roll the intensity control down. We go to 2440. So we drop about 60 volts. So that's about right for the intensity control on this scope, at least from the beginning. There wasn't a lot of adjustment range, but that could also now be a problem. So in taking a look at the schematic, I was kind of focusing around here, but I didn't ultimately understand how this oscillator worked to start with. So, and it's actually kind of strange the way it does work. V303, which is one of their vacuum rectifiers, hooks to the cathode. V304, which is the other vacuum rectifier, goes right to the grid of the CRT. Now the grid's going to be our main control over brightness. In poking around in the high voltage section, I found a couple of resistors that were out of tolerance. This resistor is 9.5 meg, so it's way out. These tested better, but I believe this 1.5 meg resistor was a little bit out too. The capacitors tested okay, but I'm concerned about this resistor, which is also going to throw off the bias because this is a weird feedback loop kind of scenario. So we have the main oscillator for T301, which is up top on the scope, but the intensity control comes out to plate, goes up through this biasing element. We have focus control here, which hits a control grid, and then we go into V301. Now I thought V301 might be the problem, so I took this tube out and tested it. V301 is fine. Everything's absolutely okay. So V301 is not our problem. So I'm starting to suspect we have some biasing resistors in here that have drifted out of value, and then we have some biasing resistors in here that may have drifted out of value, and that's what's causing us to skew and not have enough adjustment over the CRT. So what happens is this comes in here, but then V301 through this connection right here, C300, this 1 microfarad capacitor, feeds back into V302 to control V304. So it's this weird oscillator dance to get the intensity control. It took me a while to wrap my head around what was going on here. All right. I have been pulling my hair out for a while trying to figure out and understand this brightness circuit and intensity circuit. Was even kind of thinking that the tube may have gone. Maybe I had a grid separation on the tube because like everything was kind of measuring up and nothing was making sense. But I think I finally found it. It's a rare fault, but you can have a weld separation in a CRT. And that would have lost grid control, but it just wasn't making sense. I had appropriate voltages here. I had appropriate voltages here. This makes sense. This measures okay. These are ceramic disc capacitors. Highly unlikely that those would go bad. The vacuum rectifiers were obviously working because taking the DC measurements, everything was working. These are supposed to balance, although this should be more positive than this voltage because the screen with respect to the cathode is how we get the grid current. So as the screen grid drives negative, we increase beam current. Now, one of the things that's always struck me with this scope is it wasn't as bright as my other scopes. Now, I didn't have any reference to go on, and this being a very, very, very vintage piece of equipment, I thought that was normal. Turns out it may have been the starting of this fault that's cropped itself up, because I think I finally found it. There's two critical bias set points, and unlike a tech scope that has a grid bias adjustment, this doesn't. It kind of self-balances. So we have cathode, which is at a negative 2,250 volts, and we were able to adjust that negative 2,250 volts. So reasonably sure the oscillator's okay, the amplifier's okay. All this circuitry can pretty much be assumed okay because I was able to adjust this, and I actually turned it way down and had plenty of adjustment left. That should have been a clue, almost bottoming out this control and having a bit too much voltage here. The two critical paths are the feedback loop into the Hartley oscillator and this voltage divider right here, which kind of sets up everything. I even measured the resistors. They seem to be a little out, but they weren't out in space. They were over. But individually, these 8.2s weren't out in space either. They were slightly elevated, but they measure a real nice 25 mega across the three, so they're well matched. And CRT caps hardly ever go bad. So I started checking this voltage divider chain, because this ultimately sets the cathode voltage, and we have the screen grid voltage, which should be more positive to the cathode voltage. Now, I took a high voltage measurement from pin 2 and pin 3 of the tube, and lo and behold, they are about 3 volts difference. So the fact that I can't control the brightness isn't very surprising, because the tube's doing exactly what it's been told to do. So I either have too much voltage on the cathode or not enough voltage on the screen, which is why I can't drive this tube into cutoff. And I checked the high voltage adjustment potentiometer. It's fine. The intensity controls in the feedback. Now, because it was an intensity problem, I thought that may have been the issue. Turns out the focus potentiometer, which is part of this voltage divider, is out into outer space. So I think it may actually be our focus pot, which is bad. So if I take a DMM, modern DMM, it is mildly disconnected out of circuit. But if I measure end-to-end on the potentiometer, I get 4.3 megohm. That's going to screw up that voltage divider, which is going to cause some problems, especially with this being such high impedance and that being off by 700,000 ohms. That's going to cause some problems. So we have a 3.5 megohm potentiometer that is testing as a 4.5 megohm potentiometer, depending on how we test. We're going to clean it, see if we can't get get the resistance to come down a little bit. If we can, we'll check the behavior of the scope. If it gets better, we'll know that's our fault and can move forward. Sourcing this particular part is going to be a trouble because it's pot. We typically don't work in these high voltages anymore, a la not tubes. And we have an insulating layer, And then we have the control. So this is a long shaft insulating control with the threads up here on a 3.5 meg ohm pot. This is going to be kind of hard to source without a donor unit. Obviously, I don't want to turn this into a donor unit. This scope is in immaculate condition for its age, so I'd like to get it fixed and repaired. But let's hit this with some deoxit and see if we can't clean it up. If we can, great. If not, we're probably looking for parts. Okay, time for some dangerous testing. We have a 3.3 meg ohm resistor bridged in to that focus potentiometer. This will bypass the focus potentiometer. However, it will not. It may bring my intensity back. So essentially, this is a proof of concept for the repair. If I get my intensity control back and I lose my focus, we know that pot's bad, and it's the problem with that voltage divider. This is very not ideal. We have high voltage right here, flying leads, everything. I mean, the standoff on this is substantial. If you are following along and you are doing this testing, you are doing so at your own risk. I'm comfortable working on high voltage. But let's see if we burn up some parts. Good news is that resistor's not glowing, but I do have a trace again, which is problematic. Once the tube warmed up. Oh, it is blanking. Okay. My trace is much better behaved. When I say that, I mean I don't have... There was a awful bright spot on this side of the tube that was flittering around and going weird. We're going to turn this off, let this discharge. I'm going to take some cathode reading, or I'm going to take a cathode and grid reading. If I have more, what I'd be looking for at that point is separation of voltages. If I have more separation of voltage, bringing this resistance down, I'm thinking we rebuild this entire chain of resistors, because a lot of these have floated in or in weird places and probably got overheated when that pot went. So I think what may have happened is we had a cascade failure of a resistor drifted out of value and took everything else with it. But let's see if that's the case. If that is the case, we'll rebuild this section of the intensity chain completely, probably. And yeah, that might be about it. Okay, you guys are going to want to keep an eye on right there. I'm going to take some high voltage measurements. We are on the cathode pin 2. Oh yeah, 1950. And the grid 19. It's not stable, but that's also fine. 19.3, 40. See, now I might be able to tweak up the high voltage. Error 25. And resistor's holding. So that's my cathode. So cathode is negative 2049-ish, 50. My grid is also still the same, 2255. So that's going to put my brightness as messed up. Well, sometimes as a technician, you got to know when to call it. In this case, it's not permanent, but it's pretty bad. I've done some more measuring, a couple of other things, and pretty much everything in the brightness section is toasted. The resistors are out of value, the potentiometers are out of value. This scope, to bring it back, needs the entire intensity section and some of the high voltage stuff rebuilt. The resistors really aren't a problem. Getting a couple of mega ohm resistors in a couple of watts wouldn't be too terrible. The real problem is the focus and intensity controls both need to be replaced as well. They're out of value. So, especially because as I didn't notice what was happening when it was going bad, but as the intensity control was stopping to work, I even made the comment to some people I was with that I smelled things getting hot, so I'm relatively sure something overcurrented, which caused those resistors to float up in value, which brought the current down, which prevented a complete cascade, which is what saved the high voltage transformer. However, pretty much everything in the focus and intensity section got damaged, other than the grid control, because there's no current in the grid control, it's just voltage bias. But that voltage divider string, everything has to be rebuilt. The good news is it was not the capacitor problem that I thought. I thought this capacitor may have been the trigger that was on the intensity control potentiometer. The IT28 passes that cap, so that was not the case. In which case, this one was not a capacitor failure, which is new and different. A lot of times it is. The other thing is, this scope was completely unrestored. If you check the previous video that I did on this, we checked it out, made sure it was worked, checked the power supplies for sanity, looked for caps that needed to be rebuilt. It was in incredibly good shape given the lab it came from. This did come in from NASA. This used to be some NASA gear. And so the scope was in great shape. It's a slow scope, 600 kilohertz, but it was in fantastic condition for its age. So it got a spot on the bench. I have also checked the power supply rails. All the power supply rails are fine, both for voltage and ripple. There's nothing wrong there. So this is pretty much a biasing problem on the CRT is what's causing the issue. But finding these two controls, especially at the values they are, is going to be problematic. The focus control specifically being a 3.5 meg pot, being a 3.5 meg high voltage pot. Cleaning that control was a long shot. I did not expect that to work. Typically, cleaning a control will not bring the resistance down. So it was quite a long shot, and as expected, there wasn't any joy. So, for now, this is going to get migrated into the shelf of to be worked on. I'm going to see if I can dig up some parts. If I can dig up some parts, we'll revisit it. If not going to scrap it, going to keep it as is. It's a fantastic demo unit, especially for taking it out and looking at it. Because if I have to pick between this and a 555, I'll take the 555. This is much more put it in front of people and let people look around with it. Whereas the tech scope, I did end up finding a tube for the 555, so probably going to get that back on the bench and take a look at it and see. If you want to see that, let me know in the comments below. And if you have any ideas what might be the problem with this scope, let me know in the comments below. I think the intensity section needs a rebuild. But with that, as always, thanks for stopping by the lab and taking a second look at the 122A. Didn't quite get through a repair today, but at least we got some troubleshooting done and have a good idea as to the path forward. As always, I am in the comment section in between videos, and if you'd like to see what's up and coming, take a look at the Patreon page. Patreons are running a little bit ahead of this video, and their support to the channel helps keep the lights on here in the lab and videos coming up to YouTube. One of the reasons why these types of videos do get posted is because patrons have asked me to success or fail if I hit record on the camera, put it up on YouTube, and that seems like a good idea because not everything gets fixed. Pretty high rate of success, but it cannot be 100%. Never will be. So with that, as always, more is always on the way, and I will see everybody in the next video. Bye for now.